In the Toyota production system, waste is typically grouped into 7 different types. These were originally developed for manufacturing, but can be very effectively applied to services. And here we're looking at waste of resources. And we have the waste of transportation, the waste of inventory, motion, waiting, overprocessing, overproduction, and defects. And I put these in this order here to spell TIMWOOD, if that helps you to remember them. Transportation considers the unnecessary movement of materials or people within a process. This means that any unnecessary movement of materials or people which is not contributing to creating output adds no value and is therefore a waste. And examples are, for example, storing work in progress temporarily instead of being able to move it immediately to the next step. Or if you have to frequently transport raw materials or parts within the factory because the layout's not optimized. Other problems with transportation is that any unneeded transportation causes delays in the production. There's also a risk of mishandling or damage or double handling, meaning that something is actually moved around twice where it's not supposed to be, or even processed twice, which directly affects our labor productivity. Another important issue is that long communication loops can affect the quality. For example, if there's a delay in reporting the problem, or if it takes longer because of the unneeded transportation to go back in the process to find out where the production problem occurred, then finding the root cause can take a longer time. Now, how can we reduce transportation? Well, you can challenge the current layout. That is one of the main ways. You can try to minimize then the transportation of material from one function to another. Now here, if we look a little bit at today, what's happening in production is that we often outsource production to either another party or even to another country. Or we have multiple production sites. Now, costs can be saved if we have lower labor cost production sites, or we can gain flexibility if we have multiple production sites. But again, we have to consider the transportation required then will become significant, and that is considered a waste. Now, by inventory, we're referring to raw materials, work in progress, or WIP, or finished goods, which is often abbreviated as FG. Now, clearly, we need inventory. We need raw materials. We need to have material that we're producing in our factory. We need finished goods. As a production planner, you need to have inventory to start your production. You need to have inventory either as raw materials or as WIP to confirm the customer orders. And sales and marketing certainly want inventory so they can ship as fast as possible to their key customers. But inventory has a dark side. Now, why is this? And this is a very interesting part of Lean. Inventory is often a symptom of problems in the process. Now, what do we mean by that? And this is in every single textbook. So I said I wasn't going to put it in here, but I'll still draw a little picture. Let's say we have a sea, and there's rocks in the sea, right? And the sea level, the water level is quite high. So you can sail in your boat comfortably over the rocks. So if we let this water represent the inventory, we would look at this picture and say, this inventory is good. This is covering the rocks so that we can sail. Well, the idea, I draw my same picture here. If we bring the water level down, what's going to happen? Well, our boat can hit the rocks, right? Crash. So You think, well, that's not a good thing. But what this is trying to represent for us is that once you know a rock is there, and by these rocks we're representing process problems. Once you know these rocks are there, well, then you can get rid of them. So the inventory that is built up in your system is hiding the process problems. I mean, maybe rocks is not the greatest idea there, but because you can't remove them that easily. But the idea is if you have a process problem, you can hide this with excess inventory. Some part is been produced badly, well, you just pick the next part. You just ship on the next part because you have plenty of them. And what's also important is that inventory increases operational costs. You have cost of moving it around, cost of storing it. There's a risk of obsolescence, and capital is tied up in that inventory. And inventory, as we'll also see later, increases the production lead time. So the idea is that inventory is a waste because it has a dark side. It is hiding process problems. It is allowing you to continue to process and to continue to process defective parts, because if those parts are affected by the process problems, and then you can hide them because you have enough excess inventory. So we'll look at that again later as well when we look at defects. How can we reduce inventory? Well, practically, you need to define necessary inventory levels and then gradually minimize these by reducing the batch sizes, for example, limiting the work in progress. And we'll see this later when we talk about just-in-time production and we talk about Kanbans. The next waste is the waste of motion. Now, this is a little bit different than transportation. Transportation was considering unnecessary motion in people or materials, and how here at motion we're looking at unnecessary movement of people or machines within a process. And what this means, today we talk about ergonomics. We're talking about the quality of the work life, the person performing the process, and it's also important for health and safety reasons. And examples are movement of people to, for example, to fetch the tools to do a changeover, movement of the machine operators between different controls of a machine, or necessity that someone has to stretch or bend or move in an awkward manner in order to complete their task. So how can we reduce wasted motion? Well, you can check. You can see if the manual or the machine work cycles contain unnecessary motion elements. Check the tooling equipments around the workstations. Are they optimized? Can people reach things easily? Do they have to make some awkward movement to complete their job? And is the layout optimized, especially if you have varying customer demands? And that comes into this idea of when you have changeovers. If you have to change from different products or different varieties of product, is the layout optimized for that? Now we come to one of our most important wastes, and we've already looked at this with our iced lemon tea stand. Waiting means when people or machines are waiting for the completion of a work cycle. Waiting reduces our flow of products to our customers, and any waiting means that someone or something is not working on output. And additionally, waiting is boring. For the people working on a process, waiting is dehumanizing, it's thought-numbing. And for example, remember we had our iced lemon tea? What is the saying there? A watched pot never boils. So while you were waiting for the water to boil, that was waste of waiting. Now, waiting occurs in production when people or machines wait for the completion of a work cycle. They wait for raw materials to arrive. They're waiting for the maintenance to come and fix a machine. And how can we reduce this? Well, for example, does the machine need to be monitored? Could we put in built-in checks to stop the machine from producing defective products and then free up that worker to do something else? Is the production line balanced so that people and machines have minimal idle time? Or can the idle time be filled in other ways? Could the worker do quality checks, cleaning, material handling, preparation maybe for a changeover? What else could be done with that time? Now we come to overprocessing, which is any operation or process which is not required to meet the customer demand. So we sound like we're back in course 1 for define. Examples: producing to specifications tighter than the customer requires, doing unnecessary quality checks, performing operations which are not required to produce the final output. And overprocessing often happens when the standards are difficult to define. For example, how well something is polished or how nicely something's painted. How can you reduce these? Well, again, we're looking at the customer expectations. Customer expectations need to be understood. And these need to be translated into the correct specifications. And then what's key here, these have to be followed. These have to be communicated and followed to the design team and to the production team. Overprocessing, for example, can happen when an operator is doing a very good job. That person may be very good at the painting job and do more than is required for the customer's expectations, which is not bad. The person has pride in their work, is doing a good job, but it takes time away, productive time for creating new output. Overproduction means producing sooner, faster, or in greater quantities than the customer demands. For example, and this is a very common one, producing in larger batches. Now, why would you do that? We'll see that also later. We're going to try to avoid changeovers, because remember, changeovers, oftentimes we had waiting, often leads to waiting, which is a waste. So you produce in larger batches, but this means you're producing maybe more than's requested. Or you're producing, like we said with the defects, you might think there's a potential quality issue, so you produce a little bit more. Overproduced items, though, end up as inventory or scrap. And this means then you're creating other waste. It also takes time away from value-added activities. So how can we reduce overproduction? Again, we need to understand what is the customer demand, and produce only what the customer wants and when it is needed. Now, the last waste is defects, and we already talked a lot about defects earlier. Do you remember this process flow for the crayons? Now, we said, like, in this case, if a defect occurs somewhere in our process, it could mean that we've produced or even delivered a product or a service that does not meet the specifications. Now, why was this causing waste? And here we've already jumping straight into the heart of our lectures for this course. Before the defect occurs, we put in raw materials, right? And if the defect continues out to the end of the process, we're also putting in capacity to work on or to produce this defective part. We put in labor that's also working on this defective part. And so we've lost capacity, and if we have a capacity constrained process, this could be a big problem, because then we have a lot of demand, and we need every minute of our capacity, every unit of our capacity to produce good parts. And these we termed internal failures, internal costs. If these parts get out to market, then we have these external failures. Now, again, we don't have to go through this again, but what could these be? Warranty costs. They could be recall costs, lost reputation. This means maybe reduced prices. Maybe we have a reduced market share. So we could have some very big costs here due to external failures. And the other thing we talked about was if you say, well, defects, it's okay, 1% defects is okay, This means that you're allowing in your company a culture of allowing defects to occur. And again, a defect is a waste. We saw that even a relatively small percentage of defects in the parts can accumulate to substantial failure rates for the whole. So, defects. Producing product that does not meet specifications. Examples. Well, if you have products that don't meet customer specifications and you have to rework them, you have to spend extra time on them repairing. That's time that is not value added. It should have been done right the first time. Or you have delays. You have equipment that is not adjusted correctly. The product parameters are not meeting the target, so you have to adjust the equipment. And there's delays. Or worse, you have scrapping of defective product. Or, because we said the costs out for external failures. Now, causes, we've looked at this as well. We could have the wrong method, the wrong materials, the wrong machines, manpower, environment, many different causes of defects, but how can we reduce them? And you should all be saying, you know this. You want to improve the process capability, you want to analyze and solve the root cause of the defects, etc., etc. So here we move into our Six Sigma mode, of course. So we've just looked at the 7 types of waste that are normally mentioned in lean production. We're going to be looking closely at these throughout this course and seeing the quite remarkable impact they have on operations, on our productivity, and on the bottom line.